In problem number 4 in section 1.5, we're going to take a look at what's happening. At a daycare, 20% of children have a particular strain of a cold virus. Choose the correct interpretations of this percentage. There may be more than one correct answer. So what we need to realize is they gave us a percentage that's related to what percentage of children have a particular strain of a cold virus. Notice all of the answers are phrased the same way. So many children out of so many over here at this daycare have a particular strain of a cold virus. So all we're trying to really do here is express this percentage different ways and see which one of those ABC can we check off as being correct. So what we have here, if we have 20% of the children having a particular strain of a cold virus, let's remember what percent means. Percent means per 100, so 20% is 20. Per means divided. We divide 20 by 100, so 20% looks like this. So what does that mean? 20% of the children have a particular strain of a cold virus. It means that 20 out of 100 children have a particular strain of a cold virus. So B would be correct. What else can we do? We can take that ratio of 20 over 100 and divide both numbers by 10, which is equivalent to crossing out a 0 and say that 2 out of 10 children have a particular strain of a cold virus, so A would be correct. Now, if we take that 2/10 and we divide both the numerator and the denominator by 2, just reduce the fraction, we get 1/5. So it means that 1 out of 5 over here children have a particular strain of the cold virus. So A, B, and C are all correct. Check mark on all of those. Now let's take a look at problem 5. Jack flips a fair coin 70 times and see heads 39 times. What is the experimental probability that he will say heads? So what we have here, out of 70 times, he saw heads 39 times. We want to know what's the probability that he will see heads and express that as a percent. So what we need to do is divide the number of heads, which is 39, by how many times he flipped the coin, which is, he did that 70 times. Use a calculator, and we want to round to the nearest hundreds of a percent, as needed. So if we divide 39 by 70, and we know we want to round to the nearest 100, so we need to have 4 decimal places that we are taking. So let me write what we have. We have 0.55714. We're thinking about just keeping 4 decimal places, so we're thinking about that one. Because to the right of it we have a number 5 or less, we're just going to write that as 0.5571, leaving the 1 alone. Now writing it as a percent, we're talking 55.71%. So they just want that much over here, since the percent symbol is already written, so we're talking 55, and that's 0.71, and that's percent. That's my answer, 55.71. So now let's go ahead and take care of number 6 right here. In this particular problem, we have Jack flips a fair coin 50 times and see heads 33 times. So that's important to notice that this is my blue information. We have the number of times is 50. Out of those 50 times, how many times does he see the coin landing heads up? That's 33 times. So for the total number of times, I will put that in a square box. And then for the number of times the coin lands heads up, I'll put that in a little circle, oval shape. So now they're asking us how many heads should he expect to see if he flips the coins 200 times. How many tails should he expect to see if he flips the coin 200 times? So notice over here in the question they're asking, we're talking about not 50 times, but more times, 200 times. So we have to see how the 50 relates to the 200. And now we want to know how many heads do we have. So we don't know this right here. So let's use just those two pieces of information. I know they're talking about tails later on, but let's just concentrate on this much. What we can do, since we want to know how many heads and we're not sure how many that is, we can go ahead and focus on putting that, since we're writing a ratio, the number of heads in the numerator. So we'll have a pattern saying number of heads, number of times the coin landed heads up, divided by the number of, flips of the coin, the total number of flips. So we'll set up this ratio with the blue information. So just looking at those two together. So we are saying that we have, for the number of heads, we have 33, that's the numerator, divided by number of total times we flip the coins over 50. And that's equal to, now if you look at the red information, we don't know how many heads, but we know it's 200 times total. So the number of heads over here, I don't know what it is. For the second one, you could call it X or dot dot dot, whichever. And then that's divided by 200. This we do know, the number of flips total is 200. So what are we going to do now? We're going to try to find what that numerator right here is. We could either solve an equation, or better yet, I'll show you a quicker way to get there. You can think about, how do I go from a 50 to 200? I time 50 by 4 and I get 200. So how do I get this numerator, the number of heads to expect when you flip the coin 200 times? We do the same thing for the numerator. We're going to, just like in the denominator we time by 4, we're going to time by 4. So 33 times 4 will give me my answer in red. Okay, so that's 132. So 132 is the number here that I should put in the numerator to preserve that proportion of how many heads we have out of how many total flips. So that's one way to do that. Let's say you didn't have numbers like 50 and 200 that related to each other with a factor of 4. You could just solve a little equation and you would have that 33 over 50 is the same as, I don't know how many heads, call that X. Okay, how many heads is X over 132? And you would go ahead and cross multiply, and you would get that 33 times 132 is 50 times X, and proceed with that information. I just realized I made a mistake, sorry about that. That denominator is not 132, it should be 200, sorry. And we don't know the numerator is X, okay? So we're trying to solve for X, so let me fix that, sorry about that. So what do we have? We have that 33 times 200 is equal to 50 times X. And we need to go ahead and find how much X is by solving this little equation. So now the right hand side, 33 times 200 is 6,600, and that's 50 X's. So to solve for X, you have 50X is equal to 6,600, divide both sides by the number timing X, divide by 50, and you get that X is, and get rid of one little zero, 660 over 5, and you will get that your answer will be indeed 132 that's how many heads he should expect to see if he flips the coin 200 times. So X over here would be 132 done both ways. Now, how many tails will he expect to see? You do not have to set up something that complicated for the second one. Just realize the following, that if he did flip the coins 200 times total, so he has 200 flips of the coin, and out of those 200 we have 132 that happens to land heads up. So how many will be tails up? The rest basically. And how do you find how many here are T's for T for tails? Then you just subtract from 200 132. So the number of tails will be 200 minus 132, which gives you 68 times he will be able to see the coin landing tails up. So sorry about setting up my proportion incorrectly. I hope you realize that it's the same as the one above, and you do not know what's inside over here. You do not know that it's 132, so you call that X until you find what X is. Okay, so let's wrap this one up and do the next bunch.